Alright, so here's example 2 with the chain rule. So we have y equals the quantity 2x minus 1, then squared. We want to know what's the derivative of y primed. So I know we said in the last video that we weren't going to do this, but I think it's a good idea just so that we can highlight what's actually happening here. So we'll end up doing this one just like we did example 1. Sorry, I know we said we wouldn't, but again, I think it's a good idea to do it that way. So we want to identify what's the big guy, what's the little guy. Well, in general, to do that, start at the x, and if there's more than one x, just start at any one of them, and then just work your way out. Okay, so here's an x, what happens to it? Well, multiply it by 2, and then we subtract 1, and then we square all of that. Okay, so the last thing that happens is squaring, so that's our big guy, alright? So squaring, that's our f. Let's use a different color here. So the big guy, the outside guy, that's f. Alright? And then the little guy, what's on the inside is 2x minus 1. So that's our g. Alright, so in other words, f of x is x squared. Okay, the big guy, f, is squaring things. So in other words, f of x is x squared. And then g of x is 2x minus 1. Okay, so then what's y? Well, y is, zoom out a little bit, y is 2x minus 1 quantity squared. So 2x minus 1 quantity squared. Alright, but 2x minus 1, that's g of x, right? So this is really g of x quantity squared. And if you square things, you know, that's our function f, right? F of x is x squared, therefore f of g of x is actually g of x squared. So g of x squared like that is really f of g of x, right? So this is actually what y is. Okay, y now is f of g of x. So the chain rule says y primed is going to be f primed of g of x times g primed of x. Okay. Now we got to figure out, all right, what are these guys? Well, let's come back up here. If f of x is x squared, then that means f primed of x is 2x. Alright, but we don't really want f primed of x, we want f primed of g of x. Well, okay, then f primed of g of x equals, if f primed of x is 2x, then f primed of g of x is 2g of x. And g of x is 2x minus 1. So this is going to be 2 times the quantity 2x minus 1. And let's just leave it like that for now. So now we can come over here and say, alright, y primed equals f primed of g of x, we just found out that's 2 times the quantity 2x minus 1. Alright, and then we multiply by g primed of x. So again, that's a little more straightforward. If g of x is 2x minus 1, then g primed of x is actually just 2, right? Derivative of that's just going to be 2. 2 minus 0, really, but minus 0 is just like doing nothing. So we'll just say g prime of x is 2. So then we multiply by g prime of x, which is 2. Alright, and then we end up with, if we simplify, we're going to have 2 times 2 is 4. So 4 times the quantity 2x minus 1. Distribute the 4, and we get 8x minus 4. Alright, so y primed equals 8x minus 4. And that's the derivative here using the chain rule. So that's sort of the long drawn out way, and it's good to do this for the simpler examples so that we can see actually what's going on here. So let's go ahead and do it the quicker way also, where we don't write out all the details, but we just talk about it in terms of big guys and little guys. So it's important to be able to get used to doing the chain rule like that, because you know, your functions won't always be as simple as this. You know, 2x minus 1 quantity squared, not really too complicated. But as you go on further in calculus, you'll have really nasty functions that you'll need to take the derivative of sometimes. And thinking about it like the way we just did won't really be so practical. But anyway, so let's also get rid of this f and this g here. Alright, so let's just think of this in terms of big guys and little guys. And we're not going to write out what's f and what's g and all that good stuff. Okay. So y equals 2x minus 1 quantity squared. Zoom in a little bit. So chain rule says that y primed equals the derivative of the big guy evaluated at the little guy. All right, what's the big guy? Well, again, here, squaring is happening to everything, right? So start at the x, we multiply by 2, subtract 1, and then after that we square it. So the last thing that happens is squaring, so that's our big guy, right? If you start at the x, work your way out, then the last thing that happens is going to be the big guy. So, or another way to think about it is the big guy is the one that affects everything, right? And here, the squaring is what affects everything. So that's our big guy. And the derivative of that is going to be, that's just a power, right? So we bring down the power, and then chain rule says leave the inside alone, or in other words, evaluate it at the little guy. And then the power up here, we subtract 1, right? So 2 minus 1 is just 1, or, you know, so the first power is just like nothing, right? So we'll just leave it like that. So this is the derivative of the big guy evaluated at the little guy, and then multiply it by the derivative of the little guy. Little guy is 2x minus 1, so its derivative is just 2. So that's what's happening there. So this is basically this 2 out here and this 1 in the exponent, that's the derivative of the big guy. Okay, derivative of the big guy evaluated at the little guy multiplied by the derivative of the little guy. Alright, so this is 2 times 2 is 4, so 4 times 2x minus 1. Expand that and we get 8x minus 4. So same thing we had before, right? It's the same thing there. So again, this is a quicker way of kind of doing this chain rule stuff here. This is a prime, that's a prime, but this is the number 1. Just want to point that out there, right? That's number 1. Okay, so that's the quicker way with the chain rule. Now, there's actually another way to do this without the chain rule, so let's just go ahead and see that real quick. Y equals 2x minus 1 quantity squared. What can we do with that? We can actually FOIL it, right? That's 2x minus 1 times 2x minus 1, okay? And if we expand that, or if we FOIL it, what are we going to get? Well, first gives us 4x squared, oops. First gives us 4x squared, right? Outer minus 2x, inner minus 2x, so that's minus 4x. And then last, minus 1 times minus 1 gives us plus 1. Okay, so that's what y is. So now we want to know what's y primed. Okay, so we can just differentiate this term by term, and this is just straight up power rule, and there's no chain rule anymore. So the derivative of that's going to be 2 times 4x to the first, which is just 8x, right? And then minus 4. Okay, so there are 3 different ways, really technically sort of 2, I guess, because the first 2 are kind of the same. But the first way we did it was in a lot of detail. The second way was less detail, which is good to be able to do with a chain rule, especially if you're going to have more complicated functions later. And then the third way is, you know, first we simplified this algebraically, or not, I guess not really simplified, but we messed with it algebraically a little bit. We just expanded it, or we FOILed it. And then that allowed us to take the derivative without the chain rule. So if you can do something like that, if you can modify your function algebraically somehow, so that taking the derivative is easier, or if you don't have to use any complicated rules, you know, go ahead and do that if you can. That's never a bad idea. Okay, so the chain rule is not really too complicated, I guess, but this is certainly much easier than using the chain rule on this, right? But anyway, there's 3 or maybe just 2 different ways of finding the derivative of this function here, and the derivative is 8x minus 4.